So the next example, I want to show you the same function that we previously calculated numerically, and that function was x squared plus 3x minus 1. So the question is find the derivative. And I remind you that in the numerical calculation that we previously did, so we did only f prime of a, and then a was 1. So basically we did only f prime of 1 numerically, and the answer was 5. Because if you remember, it was 14, then it was 8, then it was 5.1, 5.01, etc. So it was approaching 5, so the answer was 5. Now I want to do it algebraically. So let's calculate this derivative algebraically. Once again, whenever we do any derivative algebraically, we start with this formula, limit as x approaches. So f prime of x equals limit as h approaches 0. Not x, h approaches 0, and x, we assume that it's a constant while calculating this limit. F of x plus h minus f of x, all of that over h. Once again, what we need to do is we need to expand both f of x and f of x plus h using the given formula. F of x is easy, it's just the copy of this formula. However, there is a minus in front of that, and this means that it has to be in parentheses. Minus x squared plus 3x minus 1 in parentheses, because this minus will eventually distribute. Now, for the first part of the formula, we have to plug in x plus h. And again, either mentally or physically, you erase x in both places. In any places where x occurs, we replace it with x plus h. So when we replace x squared, it becomes x plus h squared. When we replace 3x, it becomes 3, and since it multiplies x, so after replacement, it will multiply x plus h. So it has to be again in parentheses, because it will eventually distribute, and minus 1 should be here, minus 1. So minus 1, and then minus the original function in parentheses, x squared plus 3x minus 1, all of that divided by h. So that's the first expansion. So we expanded f of x plus h like this. We replaced x with x plus h, and we expanded f of x like this. And since there is a minus in front of f of x, so we put it in parentheses. So that's the first step. Now the next step would be just to expand all of this to cancel whatever cancels, and then eventually we'll do the same like before. We will factor out h, we will cancel with h in denominator. So let's do this. So it will be limit h approaches 0. Here we have, we already had this formula, so x plus h in parentheses squared will expand as x squared plus 2xh plus h squared. So I remind you that this part expands x squared plus 2xh plus h squared. Now this part, 3 times x plus h, well, it expands just by factoring in 3. And remember that 3 multiplies both x and h, so it will end up plus 3x and plus 3h. Now minus 1 will stay by itself, and this minus will distribute, so it will be minus x squared minus 3x and plus 1. All the algebraic manipulations should be correct. I already said that students or whoever is studying calculus should know algebra and algebraic manipulations really well in order to be able to manipulate with formulas and do other calculations that are required to do calculus. So this is the entire numerator, pretty long, and then divided by h. Now let's try to perform some calculations. Well, x squared can be cancelled here with the negative x squared. What else? Positive 3x and negative 3x can be cancelled. And finally, negative 1 and positive 1 can be cancelled. And I guess nothing else we can cancel anymore. So let me write up what happens after cancellation. 2xh h plus h squared. Then we have plus 3h, nothing else, so everything else gets cancelled over h. Once again, the next step is to factor out h, and once again, at this point, we should know that we are on the right track. Why? Because there is h in every term, so we can take it out. Now, again, this is where you can catch some mistakes. For example, let's say that you forgot, I mean, this is all long things, let's say that you forgot minus 1 at the end. Sometimes students forget. So if you forgot minus 1, then this minus 1 will not occur here, and this minus 1 will not cancel the plus 1. So the plus 1 will stay by itself like this. And now you will not be able to factor out h because you cannot factor out h out of plus 1. And this is how you know that you're doing something wrong. So now, if this is the case, if this happens, then you will double check your work, go back, so put minus 1 where it belongs, and then cancel this plus 1, so this plus 1 will disappear. And now you know that you can factor h, and this is an indication that you are on the right track. So now let's continue. Limit as h approaches 0. You factor out h. You have 2x. Then plus. Then you have h. Then another plus, and then you have 3. So this is after you factor out h, and then h in denominator. Once again, next thing you can cancel the h because it's not 0, just approaching 0. And then you have 2x plus h plus 3. 2x plus h plus 3. And the last step, you plug in h equals 0, or we plug in h equals 0. And it is allowed because it's a single formula. And so after plugging in like that, we get 2x plus 0 plus 3, which is just 2x plus 3. And this is the final answer. So what we got is that for a function, for the given function x squared plus 3x minus 1, the derivative equals 2x plus 3. It's the derivative of the function, so it's f prime of x. And now, if we need to find the value of the derivative for any x value, for example, for x equals 1, we don't need to do it numerically anymore. So all we need to do is just plug in 1 for x. So we will get f prime of 1 equals 2 times 1 plus 3, which happens to be 5. And this is the algebraic way of calculating the same derivative that we previously calculated numerically. Of course, we got the same answer.